Let us discuss about combined effect of drugs. Let's start the video. See, when you give two drugs at the same time to the patient, three things can happen. One is either these drugs will not have any effect on each other, okay, no effect on each other, or two drugs will combine and increase the effect, okay, so that is synergism. That means the effect will be more, right? Or third thing is these drugs, they may inhibit each other, and this is called antagonism, right? Antagonism, right? So when you give two drugs at the same time to the patient, three things can happen. One is no effect on each other, or the functions of these two drugs will combine and will have increased effect, right? So they may add up their effects, right? Third is they may inhibit each other. Clear? So these three things can happen. Now we'll focus on this synergism and antagonism, right? As I told you, synergism in the sense the two drugs will facilitate the actions of each other, right? So the effect will be more, the effect of each drug will add up, right? So this is synergism. In antagonism, what we find is we'll see that the two drugs will inhibit each other, right? This is what is called antagonism. Let's see the first one, that is synergism, right? Synergism. So let's put this into definition form. When the action of one drug is facilitated or increased by the other drug, then they are said to be synergic, right? They are said to be synergic, okay? This is what is called synergism. So suppose you are giving A drug, right? You are also giving B drug, right, to the patient. Now the effect will be A plus B, right? This is what is called synergism, right? So if the effect is A plus B, then it is called additive synergism, right? Now in the second case, you are giving the two drugs, but this time the effect will be greater than A plus B, right? And this is called supra-additive synergism, right? So here we have two types of synergism. One is additive, second one is supra-additive, right? Let's see the examples for these two things, two categories. One is additive. The first one is additive. As I told you, in additive, A plus B is equal to A plus B only. That means the effect will be added, right? And here the examples are, if you give aspirin and paracetamol at the same time, the effect will be additive, right? If you give nitrous oxide plus halothane, then the effect will be additive. What is that effect? General anesthetic effect. As you all know, what is the effect of aspirin and paracetamol, that is analgesic action, right? So these are two important examples. We have some other examples also, like amlodipine plus atenolol, which have got antihypertensive action. Okay, just remember the concept, right? Now let's see supraadditive potential, supraadditive synergism. As I told you, in supraadditive synergism, what we find is the effect will be greater than A plus B, right? So in supraadditive, what we find is A plus B is equal to greater than A plus B, right? If you take examples, acetylcholine plus physostigmine, right? Physostigmine. Other examples like levodopa plus carbidopa, right? Other one is adrenaline plus cocaine. Okay, these are some examples. Now let's move to antagonism. Antagonism. As I told you, in antagonism, what happens is the drugs will inhibit each other action, right? So let's put this into definition form. When one drug decreases or abolizes the action of another, the action of another, right? This is what is called antagonism. That means A plus B is equal to less than the action of A plus B, right? This is what is called, this is how we represent in the form of formula, right? This antagonism is of four types. Let's see that. So we have four types of antagonism. The first antagonism is four types of antagonisms, right? The first one is physical antagonism. Second is chemical antagonism. Third one is receptor antagonism. Fourth one is physiological or functional antagonism. Right? So these are the four types of antagonisms. Let's discuss each one of these. The first one is physical antagonism, right? Physical antagonism. Here the physical property is being used, right? And this is based on physical property. Suppose if you take charcoal absorbs alkalides, right? This is based on physical property, that is absorption. This charcoal absorbs alkalides and this prevents the absorption of alkalides, right? Prevents absorption of alkalides, right? So this is based on physical property. What physical property? Here in case of charcoal it is absorption, right? So charcoal absorbs alkalides and prevents the absorption of these alkalides, right? This is what is seen in physical antagonism. Let's see chemical antagonism. In chemical antagonism, as the name itself indicates, it is based on chemical property, right? Chemical antagonism. Here, as I told you, here chemical property is used. That means here the two drugs will react chemically, right? Here two drugs will react chemically, and this reaction will leads to the formation of inactive product. Okay, so the two drugs are combining each other chemically, and that results in production of or formation of a chemical product which is inactive, right? Which is inactive product, right? So if take examples, examples include tannins plus alkaloids. It results in the formation of insoluble alkaloidal tannins, right? Insoluble alkaloidal tannate, right? So here tannins and alkaloids, they are reacting chemically each other, right? And that resulted in inactive product, right? This inactive product is insoluble alkaloid tannate. Clear? And this is about chemical antagonism. Let's see physiological antagonism. As the name itself indicates, physiological antagonism, here these receptors, they react physiologically. They are based on physiological property, right? So let's see physiological antagonism, right? So it's based on physiological property. If suppose, let's take example, histamine plus adrenaline. Here these two drugs, histamine and adrenaline, they act on different receptors. Histamine act on one receptor, adrenaline act on some other receptors, some type of other receptors, right? So here these two drugs are acting on different receptors, right? Acting on different receptor, but still they are acting as antagonists, right? So adrenal and histamine act on different receptor, but still they are able to antagonize each other, right? And this property, this mechanism is called physiological antagonism, right? Next we'll move to receptor antagonism. Here in receptor antagonism, they act on same receptor and antagonize each other. Clear? And this receptor antagonism is of three types. One is competitive receptor antagonism, second one is non-competitive receptor antagonism, third one is non-equilibrium antagonism. Clear? These are three types of receptor antagonism, right? Now let's see each one of these. In in competitive antagonism, what happens is these two drugs will compete for same receptor, right? To be specific, same site and receptor, for same site and receptor. Suppose this is receptor, right? We have a site for attachment of agonist and antagonist, right? Both agonist and antagonist, they both are acting on same site of receptor, so that is what is called competitive. In non-competitive, here they act on different receptors. Suppose this is receptor, we have two sides, this is one receptor and this is one side and this is another side. Here these drugs, they act on different receptors, one act on here and other act on here, right? But still they are able to antagonize each other, right? This was what is called non-competitive. In non-equilibrium antagonism, here the antagonism is permanent, irreversible, right? In about two cases this is actually reversible. It's like, if the concentration of antagonist is decreased, then that agonism will come down. But here non equilibrium, what is happening here is, here the inhibition is permanent, it's irreversible. Suppose this is a receptor, we have site, right? Here antagonism will bind here, and it binds permanently, irreversibly, right? This is what is called non-equilibrium antagonism. So this is brief explanation about uh, combined effect of drug, and refer your books for further information. Thank you for watching.